Well, welcome back to the BS and Beer Show. I'm Travis Brungard. I'm in Prairie Village, Kansas, currently drinking a Colette from an insulated holder because it's really freaking hot here, almost as hot as it is at Dan's, but we'll get to that next. Of course, you guys all know that we're back here for BS and Beer, and the BS stands for Building Science. Tonight's topic is actually a part two. It's spray foam and how to get it right. I've already introduced myself. But now I'll introduce the BS and Beer Show, which is an independent grassroots movement to share building science knowledge through local meetup groups. And of course, the show. The brew crew and our guests volunteer our time each month to bring you what we hope is a fun and informative discussion. We encourage you to start your own local group, which I think there might be, is there 37 now, Mike? It's an obscene amount of.
Yeah.
You're a legion. So yeah, be part of that. Encourage you to start your own. There's information about how to do that at the bsandbeershow.com. And of course, you can check out our December 2022 show where we went more in depth on that. You can find the chat box icon at the bottom of the screen, and that's a good place to post your questions and comments. Be sure you click it to all panelists and attendees or everyone. Otherwise, Zoom wants to revert back to panelists only, and then there's no way we can share all that. So the video of tonight's show will be available at Green Building Advisor, and all past shows can be found there, as well as on our YouTube at the bsandbeershow.com. Thanks to Green Building Advisor and of course Fine Homebuilding Magazine, our media partners. In terms of announcements, we've got the Building Science Symposium series. It's back this fall with 2 more chances to get in on the action. First in Boston, September 10th and 11th, and then in Chicago on October 8th and 9th. We've got some fantastic presenters, and I really look forward to seeing you all there. We got Straw, we got Steve we got just fantastic everyone. So come and do that. But for now, let's talk to Mike.
Thanks, Travis. I was just posting links in the chat to those symposiums. I'm Mike Maines, residential designer in Maine. I am drinking a Lone Pine Bright Side IPA, one of my favorites out of Portland. Speaking of Portland, our surprise guest tonight is Dan Colbert. Emily had an emergency, so we called in the big gun. Dan is a builder in Portland, Maine, contributor to Fine Homebuilding and JLC and probably others. The father of the Pretty Good House movement, and also the originator of the BS and beer concepts. So he's a co-father to BS and beer. The title I came up with, but the whole concept is his, so he gets most of the credit. Anything else to add, Dan? And are you drinking anything interesting?
I'm drinking nothing, which is probably a really dumb idea given how hot I am.
Yeah. Tonight's guest expert is Henri Fennell for a repeat appearance, unprecedented 2 months apart, because he was just too popular in June, even with going overtime. Henri is an architect and building envelope specialist with over 50 years of experience in the construction industry. He was a pioneer in the solar industry and introduced the installation technique for field applied closed cell cavity fill foam, also called injection foam. He's designed and constructed a net zero research structure in Antarctica, along with a lot of other accomplishments, including high profile work, including the Big Dig in Boston, the Guggenheim Museum in New York, the 4 Northeast Ski Area Grand Hotels, the Park Avenue Armory, Richmond Middle School, the Fort Lauderdale Airport, and on and on. He has 4 energy-related US and Canadian patents. Henri, did I miss anything important? And do you have anything fun to drink tonight?
I'm just finishing a gin and tonic. Thank you.
Nice. Nice. Do you want to just jump into the presentation? I did get the one you sent 2 minutes ago and downloaded it.
Oh,
and ready to go.
Impressive.
If it's not too late, that's great. I mean, I made a couple of minor changes, just editorial, but
okay, no problem. I approve without even seeing it.
What I'm doing today is basically continuing the first presentation where I talked about the things that can go wrong with the foam installation and how to prevent them. And then answering, there were a lot of questions. We answered some during the first half of this. And what I'm doing today is I have a slide for each question that we didn't get to. And I'm going to answer those. And of course, anybody can talk about an additional question or sub question, I call them, if they want to. So this is the first one. Okay to go ahead, Mike?
Go ahead.
Okay. So the first person asked, how many spray foam installations go wrong? That's a good question. And the answer is nobody really knows, but this is my educated guess. I think there are, and I've been told this by the SPFA, I think there are about 50,000 installers in the United States. I personally see about 150 projects a year. No, I'm sorry, 150 projects per year is my guess at how many projects they do a year. That's what I did when I was in business, which means that 50,000 times 150 means 7.5 million projects per year. I see about 150 failures a year, but I'm only one consultant. And if that is any kind of indication, there's only about 0.2% or 0.002% of projects that have failures. But I will point out that a lot of failures are never discovered, meaning they get, the drywall goes up the next day and they get covered up and they don't smell bad, so nobody finds them. Warm climate work can hide thermal shock. If it's a long time from when the installation occurs to when the failure occurs. And sometimes foam failures are blamed on other causes, and sometimes other causes are blamed. Foam is blamed for other causes. Trying to say the opposite. So,
right.
Any more questions on that? Okay, so at some point I'd like to know what the impact of filling up a roof cavity is. Okay, I did thousands of injection jobs, so filling up the roof cavity can be either spray applied or closed cavity fill. And so there's two different techniques for doing that. So I took his question to mean either way. And if you have a 2-inch space for ventilation, that would be a code compliant method. Code requires ventilation if the insulation is air permeable. And spray foam, of course, is not, so it's not required for spray foam, and some people do it anyway. And my answer to is that necessary? Or and my answer to that is it's an emotional decision. It costs a little more, takes up space. If you have extra space in the framing, not a problem. As long as that airspace is not connected to both the indoors and the outdoors, that's the key. Is there more down below the screen, Michael?
Oh yeah. No, that's.
So think big is the is the end of it. Okay.
Just before we move ahead, Henri, I just discovered the chat box again. Allison Bales asked, and Andy Shapiro asked twice, what is thermal shock?
Thermal shock is when, during the cure period, the foam is the temperature of the substrate and or the environment, meaning the ambient temperature, goes below a critical temperature, and the curing of the foam is prevented or basically the cells contract so bad. It's like a balloon where you have you take the balloon and put it in the freezer. It's going to shrink and you're going to just the bubbles will burst in some cases. In most cases, it means that the foam isn't strong enough yet to resist the cooling, so the foam will shrink.
Got it. Thank you.
Yeah. And the cure period is how long it takes for the foam to be fully cured or the reaction to complete. Okay, so GPS, I had to look it up. I'm going to admit that. It's same as any other rigid foam board insulation versus spray or injection foam. It requires another system to create the air barrier. And what I mean is rigid foam board has joints or seams. You know, we called it knitting. So when we took rigid foam boards and installed them, we had to seal between the sheets. Some people do that with tape, which I consider a temporary air seal. But the way we did it usually was we placed the rigid foam board, attached them in place with a space between them, and then we used a one-part foam system, just like air sealing around the windows and doors.
Okay.
Yeah. The incremental R values means you can put 3 layers of 2-inch and get 6 inches of foam, where if you're spraying, you can spray any thickness you want, but it's going to be plus or minus the tolerance of how good the installer is.
I was going to add, but Allison already added it in the chat box because of the graphite additive, whereas EPS is about R4 per inch, GPS is about R5 per inch. And for those of us concerned with global warming potential, EPS is one of the best foams in terms of global warming potential.
Is that current data or with the 4th generation blowing agent?
That is with that that blowing agent. It's still I think it still comes out ahead of the HFO blowing agent. The blowing agent itself is pretty good. You know, a GWP of between 1 and 5 with the new stuff, but the resins still has a significant embodied carbon impact, whereas EPS is styrene blown with pentane that's recovered at the factory and then expanded with steam, with water.
I'm surprised it's 5, but I go by what the manufacturer says because that's the best data we have.
That's true. That's true.
And I just answered that. This
Oh.
one, we have to trust. Yeah, we have to trust the published data. I think Honeywell and DuPont are probably being accurate, at least as far as their testing goes. You know, we can only we have to go by something, and the data that we get from the testing labs, the national testing labs, is pretty consistent from one lab to the next. So I'm reluctant to say something else is right when I haven't seen, you know, the backup for the other publications. But the key to the last item, C, is thermal bridging. I think if we focus on thermal bridging and providing an extra layer of rigid foam board over a stud wall assembly or a rafter assembly, we do much more to increase the performance of the assembly, more so than having to worry about the little bits of incremental differences in the R values that come from the blowing agent. So and I have an article in I'm drawing a blank on where it is, but the just changing the profile of the spray foam in the framing bays, meaning make it thicker near the framing than in the middle, but still averaging the whatever the contract amount is for foam thickness, you will improve the performance of the assembly over having just a straight line theoretical. It would be better than rigid foam board of 6 inches thick. If you average with spray foam 6 inches, where you have 7 near the rafter, 5 in the middle, and the average is 6, you're still going to have a better performance than 6 inches of rigid.
Because it's slowing the flow through the rafters. I mean,
Yes, yeah, the wood is only R1 per inch. So if you bring, let's say if you put 6 inches of foam in the bay, you'll have R6 of wood that's involved in the insulation. If you put 7 inches in the bay near the wood, then 7 inches of wood will perform, which is R7. So that was a great question, and thank you for asking.
Kurt makes a good point in a comment, just that the most environmentally friendly foam is reclaimed foam, of course. So anything new is going to be have more of a climate impact than a new foam. Then Peter asked and Travis answered, but just for the record, I'm online. What is HFO? Can you explain what is HFO and why is it?
It's a halogenated fluoro. I think I have a slide. You want me to tell you what slide to go to, or do you want to wait till we get there?
We can get there naturally. That's fine.
right.
We
We'll
can
keep it
wait.
a surprise. We'll build to it.
Yeah, I have a whole slide on blowing agents
Okay.
later.
Okay, great. I forgot about that. Sorry.
No, it's next.
Oh, there we go. All right.
Right on cue.
There's my
Good question. So this is the history of blowing agents. When I first started in 1971, we were doing CFCs, chlorinated fluorocarbons, and CFC 11 was the go-to system at that time. And then we went to ODPs, ozone depletion potential products in the I'm looking for the years. Yeah, 2000 between 93 and 2005, and in 2005 we went to the 245 FA, which was used for a long time. I introduced in 1993 the 134A, which was before its time. When they got rid of CFCs, I said, let's go all the way to zero ODP ratings, ozone depletion potential. And at that time, there was no rating for global warming potential. So we were only dealing with ODP. We went all the way to 0 with 240 with the 134A. And then in recently, Honeywell and DuPont brought out their HFO products to get their GWPs down to near 0.
Great.
I don't know if I answered the HFO question. Halogenated fluoro.
Olefin, hydrofluoroolefin.
Thank you.
The internet
right.
says that it's all about the 0 ozone depleting potential, and that's essentially what you've got here. So There we go.
Yep.
This is a question actually that for Dan. Michigan tap water.
Jim Rogers.
Jim, okay. The question is there a role for spray foam in new construction when building a pretty good house? Most local builders around here want to use closed cell spray foam in walls as flash and bat and under roof deck. Does PGH support these approaches?
Well, PGH says, figure it out yourself, pal. But Dan Colbert says, whatever. My opinion is that I don't see a reason for spray foam in new construction, except for some very few like if you have a flat roof, maybe. But
Unventable.
What's that?
Something that's unventable.
Right.
Yeah.
Yes, and I have used it in those instances in new construction.
Yeah, me too. It's also good for a rim joist. Just there are other ways to handle rim joist, but just it's so quick and easy, and air seals all.
My comment is that if you don't use spray foam, use some other type of insulation, you have to add another element to the assembly to do the air barrier piece, and that's doable. So as long as you test your air barrier as part of doing a new construction project, I don't have a problem with that.
To Robbie Schwar's comment, I would like to add, anytime we talk about air sealing with spray foam, I feel like I have to remind people that you are probably doing a great job of air sealing within that cavity, but every connection from plate to stud to rim, every place that the spray foam isn't, the spray foam can't seal. So if you had a continuous layer that encapsulated those members, very effective air seal. If you're only infilling cavities, not effective. And that's why at a rim joist, I personally favor an exterior air management strategy as part of my building processes. But Robbie's point was that a lot of people think it's a panacea, that this spray foam application will give you this continuity of air control. And while it is a fantastic product for providing great adhesion and air control where it cannot seal where it is not.
I will just add that in a roof assembly, when I write a spec for a foam installation in a roof, I require them to wrap the framing members. And that covers the doubles, the triples. It covers where the rafter meets the valley rafter, where the rafter meets the top plate and the ridge beam and so forth. So you do cover those niggly wood to wood connections that are so painful when you do your theatrical fog or rigid or your infrared test after the installation. So
yeah, and just as a blanket statement that I meant to include in the introduction. We've had lots of shows in the past. We'll have more in the future on is spray foam good or bad? What else? How can we avoid high materials that have high global warming potential? There's a lot to discuss there, but we have Henri, who's an expert in spray foam. So we specifically titled the show, "How do you do it right?" Like if you're going to do it, then you might as well do it right and understand what the material is, how to use it, what to be aware of. So that's really the focus of the show. We'll have one sometime in the next year, I'm sure, on environmentally friendly building techniques and low global warming and all that kind of stuff. So just hold your questions for then as much as possible.
In our early days of the discussion of our building science discussion group, there were several occasions where we almost had fistfights over the subject of spray foam.
Sorry.
Oh, it was great. I was sad when they stopped happening.
Was that at Joe's or?
No, this was our local one.
Okay.
Yep.
I'll see you all at Joe's.
Yes. All right, moving on.
Yeah, okay. Yeah, my answer to, is it common to install open cell foam in all climate zones? And my answer is, depends on what the code requires. I think you should always at least meet the code. And people need to understand that the code is a minimum standard, not an average, or I wish it was standard. So when somebody tells me, well, I didn't spray 6 inches over there, but I sprayed 12 inches over here, or I didn't spray any where I find a complete void here, and I sprayed 8 inches over there, I say, no, it's the minimum standard, not the average. So if you're a specifier, make sure you require a minimum thickness or minimum R value, not an average. Or a lot of people don't require, they just say spray, spray foam in the roof or 6 inches of spray foam or whatever. But the bottom line is you need to make it a requirement that it's a minimum standard.
Henri, open cell has always scared the shit out of me. And so why, are there times when it's a better choice, or do people use it because it's cheaper?
Well, first of all, as an installer, I'm in a northern climate, and climate zone 5 and 6, I did most of my work. So I almost never used open cell foam except for interior sound control.
Because you couldn't get the R value, or because you had other concerns?
For me, for my crews and my ability to track efficiency of installation and cost, the price was so close that it didn't make sense to do anything but closed cell. And then I didn't have to install a vapor retarder, and I didn't have to install, the other things that go with open cell that closed cell takes care of. So we always use closed cell. Open cell, I think, has its can have its uses, but a lot of the failures I work on are open cell because, number one, I've almost never seen a vapor retarder installed on open cell foam, even in a climate or an assembly that needed a vapor retarder. So
You don't know. So there's no scenario where you would say that open cell is the better solution.
Well, I don't do the work anymore, but when I was an installer, the answer was no.
I'll take it.
Do you see many failures in open cell foam, or is it more common in closed cell?
I'm going to guess 50-50, but I don't track that
Right.
Specifically. But when I see a failure in open cell, it's almost always a moisture issue.
Mm-hmm.
And I mean, open cell doesn't shrink and crack like closed cell. That's about the only advantage for open cell, because it's so flexible that it can, even if it shrinks, it doesn't crack. But it does require a vapor retarder, still needs the fire barrier and so forth. So
yeah,
I never saw, to answer Dan's question again, I never saw a real reason to switch.
Yeah, but that confirms my suspicions.
Just for those watching this on via replay they can't see the chat box, but there's discussion on code. And I think we all agree that the 2021 IECC is pretty good house at this point. Like that's a pretty decent building. That said, like in Maine, we're on the 2015 IECC for the most part, except for 3 towns right now. I just heard from a friend in I think Virginia, or Kentucky, that they're on the 2006 IECC. So across the board, code is good now. Going with the old code is not so good.
I always like to remind people that most of us grew up in houses that would not pass any past 2000s code in any, not structural, not in energy values, insulation, windows, none of it.
Fire.
WRB, yeah, fire, of course. So while we like to run down the code as being the minimum standard, it's actually quite exceptional as compared with where most of us grew up and where many of us live now. My current home blows a 7.25. I haven't built a house less than 1 air change per hour in 6 years. We are doing better now, and part of the improvement is code enforcement, but you can't blame the code for a lack of enforcement. So that's a different topic for a different day. Peter's question: what do you say here, Henri?
Oh, this one, what they're thinking of, if you read a can of window and door sealant, it says spritz the substrate before you install the foam. That's because it's a water cured product. It's not a 2-part system. So if it's a 1-part product, the answer is absolutely you want to moisten it. And if you're air sealing a thick cavity, meaning think about a 3-inch wide window weight pocket. If you're filling that with a single component can, you want to put in a layer, spritz it again, put in another layer, spritz it again, and so forth, because if you don't, the moisture will never migrate to the material that's way inside the big bun, and the material will collapse and the seal will be broken. But 2-part foams are damaged by water. Water's a blowing agent. If you have a wet substrate, meaning more than 18% in wood, the manufacturers of the foam will say don't spray on that substrate. And if you're spraying on steel or glass or anything, well, even concrete, the manufacturers make the mistake of saying don't spray on a wet surface, and I make them tell me what that means, what the definition of wet is, and I have a moisture meter that will actually tell you what the surface water content is, and you can actually test to make sure the substrate is properly prepared for closed cell foam.
Dan, you want to ask this one live? Come on, man. Add some spice.
Wow. Out loud.
Go ahead.
This is, well, right, mixing foams. I can't even remember. Do we talk about mixing foams? This is my open cell obsession. Although I guess, yeah, right. But anyway, I'm assuming that my question is, should the closed cell go closer to the cold side, whatever climate you're in?
Yes. First of all, I had to assume you weren't talking about mixing the chemicals from 2 different drums of 2 different products.
Right, exactly.
Into 1 drum.
Paint thinner and old sawdust.
Yeah, right. Anyway, that's called a hybrid system. And the hybrid systems are covered in the code. And you have to have a proportion of air permeable to air impermeable insulation that's different in every climate zone. And you'll find in the code a different proportion or ratio of insulation materials for each climate zone in the code.
Does
in
hybrid refer specifically to this scenario or to any scenario where you like flash and bat or whatever?
flash and bat would be a hybrid system.
Yeah, okay.
And it's a problem that I have with the code. A lot of people call flash and bat air sealing the substrate and then putting fiberglass in the stud bays. They call that flash and bat. That's not really flash and bat, and it's not enough R value, or it doesn't have enough R value to really qualify as the intent of the code. The intent of the code is to prevent condensation in the air permeable material. So you want the dew point to occur in the closed cell foam, not in the fiberglass or the open cell or any other particular insulation material that you combine them with. And that's why, at least in a cold climate, you want the open cell on the room side or the fiberglass on the room side, not on the outside. So depends on the direction of the vapor drive. And one of my problems with hybrid systems is if you live in a climate zone where the drive is in a different direction in the winter than in the summer, you have to have these little guys in the wall that move all the insulation from one side to the other every season. So in my opinion, again, closed cell foam only, no matter which way the drive is, no matter what time of year, no matter where the dew point is, it's going to be in the right place with closed cell foam, where it may not be with any kind of flash and bat or hybrid system.
Yeah, good point. I mean, in Maine, it's certainly something that we are talking about a lot, that all of a sudden, I mean, the combination of global warming and the huge adoption of heat pumps means suddenly that we have vapor. Nobody had air conditioning 10, 15 years ago. And now it's, I don't know, I just heard a stat in the radio yesterday. I can't remember what it was, but an incredible amount. So all of a sudden we got vapor drive every which way but loose.
Yeah. So, one way to address what I call bidirectional vapor drive is to use closed cell foam or rigid foam board, styrene, foil faced, whatever.
Before you go on to the next one from Ben, let's knock out these two from the chat. What are the advantages of a 2-part foam versus a 1-part foam? And then the second one was from Peter Molliner. The question to Henri was, have you ever been invited to contribute to writing the building code updates? Oh, Michael says we'll get to that in the PowerPoint. Don't talk about the 2-part foam, Henri. Just answer if you've ever been invited to update the codes. Damn, you're fast, Michael.
What was the first part of that question?
Don't worry about that. We're going to get to it in the PowerPoint.
You said there were two in the chat box. What was the first one?
The first one is the one that will show up in the presentation naturally, so we don't have to address that one. But have you ever been invited to contribute to the code making process?
No, okay. But I have written I wrote the ASTM standard for pressurized theatrical fog because I did a project. I don't know what year it was, in the 90s that we used theatrical fog to quality control a very complicated air barrier system in electric buses in Portland, Maine. So, the only way we could really do that job properly was with a theatrical fog test protocol where we couldn't rely on temperature for infrared and so forth.
Perfect.
Don't feel bad, Henri. I've never been invited either.
You're all invited. That's the truth of the matter. The code making panel is open to everyone.
I will tell you that I will never do another ASTM standard because it was so political and full of people who were trying to prevent a code, a standard from being passed that would make their product less saleable. So I said, that's it, I'm done. Sorry to say.
All right, so back to Ben's question there. How do we know installers are working safely and not risking their health in the process? How do we ensure that non-installers are safe during install? What do you say to that?
Well, that's a, first of all, the OSHA standards cover worker safety. So if you meet the OSHA standards, you should be golden. And OSHA requires, and this is a law, that every installer have a written safety plan, aka also known as a hazard management plan. And if you're an installer or anyone who sprays anything that is a toxic chemical, you should include air quality management in that written safety plan. And obviously, OSHA talks about PPE, so personal protection equipment. And the only thing I will say is that you can probably seal around windows and doors with a can of foam and not need to wear a respirator. But if you're using a 2-part kit and you're in a crawl space, you need a respirator and you need ventilation. So, it depends on how confined the space is and how much material you're dispensing, really. If you can, my rule was, if you can smell it, you need PPE.
That's a good rule of thumb. I used to do project photo documentation in the heavy construction industry, and we would frequently have to do water treatment plants. And I once asked one of the current staff of the water treatment plant who had been there for a long time, and this is quite literally, they are cleaning sewage and making that water useful again. I was like, how do you handle the smell? And he's like, I try not to think about it, but it's killing me right now. And the best way I can express it is that if you can smell it, you can taste it. And that means that it's in your body. So if it smells like crap, you're tasting crap. And I was quick to get the hell out of there. So that's a good policy for the house where you have foam as well. If you can smell it, or if not even just for foam, hardwood floor coatings, enamel paint application, these are all hazardous chemicals. So that's really good advice on it.
It is.
Yeah, and just a little side thing. When people talk about engineering controls, that means ventilation. So
useful terminology.
Yeah. Okay. Go ahead, Michael. Okay. So air sealing, the sealing first is best practice. So, if you're going to do any attic, no matter what the framing type is, first you want to air seal, then you blow in 3 feet of cellulose or whatever you're putting over it. Because once you put all that cellulose in, you can't go back. If you do a blower door test, you can't go back and get to the area that's got an air leak without damaging the blown in. So the first step is always air seal first, then test, then put in the rest of your R value.
There's also the reasonably safe ratios of our values of closed cell to a cellulose or other fill to control condensation risk, which varies with the climate zone.
Yeah, well, I was looking at this as air sealing, meaning use the weatherization WAP requirements for sealing the top plate above a 2x4 top plate of a wall, or around a recessed light, or just air sealing, not a hybrid system. But if you put in enough sealant to have R value, then yes, you want to also meet the hybrid system standards for ratio.
So are we talking about only installation failures, or do you have data regarding long-term failures?
What's the difference between an insulation failure and a long-term failure?
It's the duration of, excuse me, it's the evidence. Is it immediate, or like, are we talking about delamination over time? Like in an under roof situation where someone fills the cavity between the rafters tight to the roof deck, and you know, it looks pretty good for the time being. There's no evidence of it pulling away in initial shrinkage, but then you do have a delamination as a result of maybe a very dusty condition where it had good adhesion to the dust that was on the roofing members and the back of the OSB. But then we go through a freeze thaw cycle, you get a layer of cross condensation in that interstitial space that was created because there wasn't really good adhesion. Then that is exacerbated and eventually becomes a larger cavity as the foam becomes waterlogged and falls in. So that's a long-term failure that initially looked like a good install. Is that fair?
Well, you're talking about open cell foam in that case, but first of all, I have seen failures that occurred while they were spraying, and I have seen other failures that didn't occur till the first cold night in the fall, you know, a summer installation. So you're right about the thermal shock being, you know, the likelihood of the cause of that when it starts, but I don't think there's a real time for how long it can take. If what I do when I'm overseeing a new install, I take my drywall knife and I slice the foam just the depth of the drywall blade. So if they're spraying 7 inches in a roof and I slit the surface, I'm just relieving, I'm cutting the skin which holds the foam together.
Mm-hmm.
The core is the lowest density and it's the weakest. The strongest is the skins, which are the highest density. So if you cut the skin, and if the cores have what I call locked in stress, it will open up immediately. So that's better than the 2022 ASTM test for, you know, cold and hot thermal shock, but you can take samples and stick them in the freezer at night or put them in your if you have an oven that you can really control the temperature of, you can do an ASTM test for thermal shock, both hot and cold. But the quick one on site, you know, a low-tech quick test is a slit test.
A long-term failure is just one that hasn't shown up yet.
Say it again, Dan.
A long-term failure is just an install error that hasn't become obvious yet.
Well, some people think a long-term, they always ask me, how long will if there's an outgassing problem and we're doing IAQ remediation, they say, how long will it be before it stops off-gassing? Well, I've seen projects that were 15 years old that were still off-gassing, and I've seen projects that stopped in 5. So I don't think there's data on that. It depends on the chemical that's off-gassing.
Right. If it
And
hasn't cured, it's going to keep off-gassing.
Yeah, it can keep off-gassing for a long time, or it can be, you know, if it's isocyanate, for example, that's a worker problem that will react with the moisture in the air within hours or days, and that's a short-term failure. But the B-side chemicals can be long or short-term off-gassing. Sorry, my answer to this is I don't think it's the foam. You know, they're blaming the use of spray foam on what's happening, I think, is that they're cycling on and off because they don't have the load calculated properly. So they have equipment that's oversized and it runs for a short time and then turns off and then it starts up again in a few minutes and runs for a short time. That's my guess. on this question, but a short cycling thing will be when I talk to people, engineers who design HVAC systems for buildings that have normal insulation. They take the load calculation from the standard calculations and they double it at least to cover their backsides. And I'm doing a presentation next week on how to guarantee air barrier performance and right size the mechanical system so you don't have that problem and so you don't waste that upfront cost. And I've done schools where the upfront cost was $7 million less in a right side mechanical system than it would have been with their big margin of error. And we know that because we bid it twice. We bid it both ways. So I guaranteed an air barrier performance that was well below the code, and the engineer right-sized the HVAC system, and it was amazingly, smaller. And I'm talking about in the Northeast. And we did several schools this way. It's a matter of right-sizing the mechanical system for the real building performance.
I'm going to start blaming things on spray foam in the attic too.
You're going to start what?
I'm going to start blaming everything on spray foam in the attic too.
It's spray foam.
Okay.
even if there isn't any.
Yeah.
Dan, I'm about 15 pounds overweight, and I think it's probably because the spray foam in the attics in the neighborhood have caused a serious issue there.
Right. Or spray foam in your middle.
In the chat, Allison, who has a mechanical engineering company in Atlanta, says coils in heating and cooling systems and dehumidifiers fail for a variety of reasons. Can be manufacturing issue, former carry corrosion. He has not heard of system sizing causing failures though.
Well, he's in the or she is in the South, and I'm doing work in buildings that are in cold climates, so that's my only excuse for what the engineer. This is what the engineers have told me. I'm not an engineer or mechanical engineer.
You guys can fire it out at Joe's.
There you go. Battle Royale.
We'll introduce you at Joe's, Henri.
This question: commissioned a third-party inspector to observe the job as being done? ? So, Henri, your point here is that someone has to check it. It's either you or the installer.
Well, on my crews, the guy pulling the trigger was never the final. Never had the final say for when the job was done. He always had to have at least two sets of eyes look at every job. And when I sprayed the coating on an attic, we used two colors. So you could see the difference between the color of the foam and the color of the paint. And then the second coat, you could see the difference between the two colors of paint. So, there's different strategies for inspection. You can hire a commissioning agent, which is a third-party inspector, or you can have your crew do it. And what my crews did, all the blower door tests, the infrared tests, the theatrical fog test, they did all those things, and we verified the jobs that we installed. So they knew, and the first time we did blower door testing on a foam job that we installed, we had to go back and do a lot of touch-up. But as we did more and more testing of our work, the number of places we had to go back to and touch up went down because the guys knew where the leaks were, and they knew how to avoid them by spraying it properly in the first place. So if you don't have people on your crews who are doing the installations who understand the bottom line, which is performance, and this applies to fiberglass and cellulose and every other insulation product, you know, they're not going to, I did an infrared scan on the house of a contractor who had been installing fiberglass and cellulose for 3 generations. He was the 3rd generation installer. And when I showed him in his house, first time he had ever looked what the air leakage was at the bottom of the rafter tails, he was amazed, and he said, I can't believe it. We've been doing it that way for 3 generations. So, you know, unless you get feedback, you don't know where those problem areas are. So, you know, everybody should either do the testing at some point or observe it, watch it while the testing is going on to really do a good original installation.
Roof structure is going to fail if he installs closed cell foam with low pitch roof with asphalt shingles.
Well, every roof, this would apply to every roof, no matter what kind of insulation, frankly. The difference is that if you have closed cell foam, you might not see the results as soon. But I get people who call me and say the water's coming out of my soffit. And, you know, what's wrong with the foam? And they think the water's coming from the foam. And what the foam is doing is it's keeping it on top of the plywood or on top of the roof assembly and letting it run out at the bottom. Well, if you get fiberglass wet or dense packed cellulose wet, the only way to dry it out and fix it is to remove and replace. So if you have a roof leak, first of all, you should always have your roof inspected on a regular basis. But if you have a roof leak and you have closed cell foam, unless it's been, you know, years and years and years, there's no damage. They can't dry out in a season. And I would say, you know, if the water's running out of your soffit, you should have the roof inspected.
Reasonable.
You cannot measure R value, to my knowledge. All you can measure is the thickness of the foam. If you, or whatever the insulation is, and multiply that by the R value of the, you know, the published R value for that product. You can send a sample to the lab and it can be tested, but that's very expensive and it's not real time. So if you look at a roof with an infrared camera, you should be able to see where there's either missing insulation or less than insulation or an air leak. So
Will uncured show up in an IR camera?
say it again.
Will uncured show up in an IR camera?
Yes, because it won't have as high an R value. But you will also see wet. You know, if you have a low slope or no slope roof under a rubber membrane, you will see where the roof is leaking because if you go there right after the sun sets, you'll see where the mass of the roof is warmer or colder before it gets a chance to equilibrate.
Just as a nerdy aside, our value testing is done per ASTM C518 at mean 75 degrees temperature. So it's between 60 degrees and 90 degrees Fahrenheit, because they're more concerned with roof performance. Most materials actually improve our value as they get colder. It's also done with foam aged carefully for 6 months, and over time, air displaces the blowing agent and the R value drops, but there's no way to know how long that'll be, right?
Yeah, no, I disagree. I mean, I agree with that. And the other thing that's I think is important when you talk about R value is most ASTM test methods don't consider air leakage or any kind of convection. So if you test fiberglass with or without air movement through it, the difference in R value can be double. But closed cell foam, you won't see that kind of difference.
Right. So Robbie asks how many CCFs are claiming or notes that many foams are claiming are 7+ per inch. That's after 6 months. At some point in the future, it'll be R 5.6 per inch because that's the R value of still air. But that could be 5 years, 20 years, 50 years. Nobody knows. Would you agree, Henri?
Yes. I mean, I don't know. The answer is we don't know because, that it depends. I would also claim that it depends on the installation because how you install the foam affects the density.
Good point.
And the density affects the rate of off-gassing, which is what you're talking about. You're talking about how much of the low conductivity gas escapes from the foam. And let me also point out that if you have a roof with plywood and ice and water shield as the outside skin, it's probably not going to off-gas much on that side. And
Fair point.
the evidence of that, if you have a cooler or freezer metal panel, the R value may be 7 or 8 initial and aged because the steel skin is a vapor barrier, not a retarder. So the rate of off-gassing is much lower, but that's an exceptional case unless you put freezer panels on your house.
Right. Polyiso, though, also has thermal drift. It decreases with cold, so that's a whole different situation. Every other material increases as it gets colder, but polyiso.
Yeah. And some freezer panels are made out with polyurethane. Some are made with polyiso. Some are made with styrene. Some are, there's all different kinds of products, but
yeah,
the metal skins help to improve performance.
Yeah. My personal approach, because I don't like using more foam than I need to, is if it's a long-term moisture issue, I use the most conservative R value, which for closed cell is around R 5.5, 5.6 per inch. But if it's to meet code minimum requirements, I use the highest possible because I don't want to use too much of it.
I think that's reasonable.
Yeah. On a related note, Allison asks, what's the R value of open cell versus closed? Oh, what's the R value of open cell versus closed cell beer?
And Dan handled that perfectly. His typical aplomb: open cell versus closed, or excuse me, open can versus closed can.
All right, perfect.
Well done, Dan.
Thank you.
But for the record, open cell is generally around R 3.6, 3.8 per inch. And because that's not relying on refrigerant blowing agents,
Right.
that remains pretty stable.
Yeah,
All
but
right.
you'll see advertisements from the manufacturers that are much higher than that for open cell.
Oh, really?
It's a free for all. Okay,
The only thing that spray foam is right, as good as it is for destroying the environment, it's even better for making outrageous claims.
well, open cell is not I mean, there's a lot of things that can make outrageous claims. I think thermal drift in fiberglass is another example of that, but have I covered spray foams that come in suitcase-sized tanks and sell off the shelf at big box stores? And I have a comprehensive program for that that we're gonna do for a whole session next year. And I have about the last 6 or 7 slides on kits and cans in this presentation. So we'll get to that.
Maybe, because we're only 19 questions through. I think we had 30 something Q&As. So,
Well, let's go faster.
all right.
Speed round. Here we go. No more chats. Let's do this.
Quick, let's get through it.
Or should we jump
Closed
on the
cell foam
slides?
structure, roof deck and unventilated attic assemblies. I've seen failures in roof decks on steep slope roof systems. 1-inch airspace. I don't have a problem with vented roofs. There's nothing wrong with it as long as the vent space is not, as long as you're not venting the roof with indoor air. And I see that all the time. You know, they want to know why there's foam with a closed cell foam roof. They've got water running out of the soffits, and all of their spray foam is connected to the indoor airspace, which is moist, humid air. So, and that roof deck is a great condensing surface. So,
Yeah.
As much as I'm not a fan of spray foam and am a fan of ventilating roofs, if I did use spray foam on a roof, I don't know why I would bother ventilating it.
I agree.
Agreed.
I think it's an emotional decision, but it's not. I don't, in this question, I don't want to say it's not allowed.
Right. No.
And it's a it's okay to do it as long as you isolate. When somebody said they wanted to vent a roof that I installed was closed cell foam, I said, if you want to vent, I'll do it. I'll guarantee it without venting. But if we vent, I'll only do it if we test it for air leakage from the interior into the vent space.
Yeah.
And I did a lot of those. So, as I say, that's an emotional decision. And I, think about a Walmart. There's no venting in that flat roof. That's rigid foam board.
Right.
So, it's a perfectly legitimate strategy not to vent, but it's also okay. You can vent it if you want.
Good.
If it's not giving proper ratio, when does off-gassing stop? The answer is we don't know, because it varies a lot depending on the density of the product. And it also can depend on the permeance of the surfaces on the inside and the outside of the foam. If you put up drywall and paint it with a vapor retarder paint, it's going to reduce the rate of off-gassing, and it can make it off-gas longer. So it varies. I can't answer that question well.
That's okay.
Okay.
See, differential thermal expansion between spray foam and the building materials causing adhesion to fail during large temperature swings. Owners.
Yeah, my answer to that is that foam has failed. It's improperly installed.
All right, properly, yeah. Great.
The bond of the foam is stronger than the than the foam itself. So that won't happen unless there's something wrong with the installation. And that can mean off ratio. It can mean it was sprayed on a wet surface. It can mean that they sprayed too thick a pass. It can mean that they used the wrong technique when they, applied it to the surface. Lots of different things that can happen, but good quality foam will not do what he describes here. Go. Thank you.
All right.
Uh,
What types
so
of is off gas?
when I started working with labs on IAQ related to foam failures, I went to a well-known lab and I said, I want to test the air and I want to make sure you're looking for all the compounds in the spray foam. And they said, well, we look for TO15 or TO17, depending on which lab you're talking to. And that's a compendium list of compounds that can be in the B side and the A side. Now, I went and looked at the SDS for the product that I wanted to do the testing for, and none of the compounds on the SDS were in the TO15 or TO17 list. So I had to go to a lab and work with a lab to develop a list of all the compounds that can be in spray foam before we tested the air for those compounds, because we don't have a standard list that includes all of the compounds in modern spray foams. It may have been fine when it was written a long time ago, but it's like, how do you test for density? The standard was written when you only sprayed 1.5 to 2 inches of foam and you took the average of the total thickness. Now we have these HFOs and you need to test the core, not the full thickness. Anyway, there are hundreds of compounds. We found when the lab and I worked together, we found hundreds of compounds. And the way that I was sure that we always knew what the compounds were in the foam, because remember, you can have third-party chemistry and you can have contaminants from other products or even from the equipment. The only way to know what the compounds are in the foam is to test a foam sample for off-gassing, make it off-gas, collect those compounds, identify them, and then look for those compounds in the air. And I will tell you that a lot of times installers don't know what the product is that they're spraying. And I don't just mean it's mislabeled or they don't know what it is. I mean, it can come from some offshore place and then it got relabeled with some, US company labels and so forth, especially during COVID. So I think you need to test the foam itself that was installed on that project, make sure exactly what it off gases, and then compare that to what's in the air.
Okay, great. Does off gassing continue as spray foam deteriorates?
Yes, and again, we don't know how long that occurs. And when you say deteriorate, if you mean off-gassing from the blowing agent slowly migrating out of the cells, that's a different answer than if you mean, does it crumble and turn to dust after 17 years? And the answer is, I have stretch skin panels that I made in 1973 that I'm using today on a roof in a project in one of my houses. So, the foam is very durable, but it's not, what changes is the R value. Low pressure systems are ones you can buy at the big box stores, and they're about 250 psi. in those cans where when you spray high pressure, when you spray closed cell foam, you may be spraying 1,500, 1,200 PSI, or you may be spraying as high as 3,000 PSI, but it's a different kind of equipment. Disposable systems are something that I think every installer should have on every rig, because every job that you do has some area with a closed cavity in it. And we always carried, we were doing spray foam. We had a spray foam truck, and we always carried a slow rise disposable kit on every truck. And if we had a closed corner or a closed rim joist or a closed, window weight box or whatever, we filled those with the slow rise system, because if you put spray foam into a closed cavity, you actually create a fire situation. So, good. Okay. No, you can go on. Foam sealant is the one-part system that we use around windows and doors. SPF, spray applied foam, that's what we see most of the time in buildings. And there are open and closed cell bulk foams, and most bulk foams have seasonal formulations. So if you see a drum with a big label that says winter use only and it's 106 outside, you want them to leave. And I've seen that. And it was on a retrofit it was a remediation installation, and the guys came to the job site with winter formula on a hot summer day.
Oh, man.
I said, out of here.
Winter is coming.
Yeah, it's always coming. Okay, so disposable systems are throwaway, which means they're very low tech. They're not high pressure systems are impingement mix, means the chemical streams hit each other head on at 1,000+ PSI, and that's what they rely on for good mix. In the throwaway kits, it's done with static mix equipment, which means it's like a milkshake mixer that A and B go through, and when they come out, or epoxy glue or whatever. The professional equipment has heating capabilities that the disposable containers don't have. And I'm going to show you a list in a minute about the quality assurance problems. The biggest one with kits and cans is temperature. So you have to do that. Completely disposable versus some containers are returnable. So a lot of spray systems and injection systems have returnable containers instead of 55-gallon drums you have to get rid of. Supply containers and guns are disposable. Okay, here's that. Go ahead. This is a thing that Terry Brennan and I put together for all different kinds of foam. And if you see 2-part slow rise and 2-part spray foam, the QA, you have to maintain thickness, to maintain temperature and so forth. The single component you need to moisten the surface between lifts and so forth. So this is something that you might want to have if you can download it or print it to compare different products and what's required for quality assurance. Next, please. Okay, personal protection. Any kind of foam needs personal protection. One component, it depends on the size again of the space and the ventilation and so forth, but Personal protect. If you can smell it, you will need personal protection. Two-part tanks are not high pressure, or not you don't want to charge them with a a tank that you would get your gas for cutting torches or anything else. They're only rated for 200 psi, and they have a pop-out plug in every tank that if you go over to 200, 250, depends on the manufacturer, those plugs will pop out and it makes a real mess. So you definitely don't want to overpressure. And you can overpressure them simply by warming them up too fast. So you need to heat them correctly, and I'll show you a method of doing that. All foam plastics must meet the IRC and IBC code requirements. People think they're exempt, they're not. And all of them require substrate preparation. The one-part kits, you need water. All the rest of them, you don't use water, and so forth. Next. Personal protection. That's an example.
Hey, Henri,
Yes.
in the previous slide, you said use bracing when required. What does that mean?
Use what?
Bracing. What does that mean?
Oh, if you're going to push, if you're filling around a window or a
Oh,
door,
I see. Got it.
and you're going to distort the jam, and then the door or the window won't move, we always just put a brace in the rough opening to keep that from happening.
Got it.
If you're injecting a wall and the drywall is wet, we used whalers on that so we wouldn't push the drywall. Good question, thank you. Anybody know who this is?
The young Ben Bogey. You can't see his
You're
beard.
all
It's
gonna
under the
see
respirator.
see him next week. That's Kodo Ueno.
Oh,
Okay, so safety first. I just want to point out that most, and I'm talking about foam failure cases, which means the contractors are not necessarily top of the line. Only about 5% of them evacuate the house when they're spraying it. Less than 1% ventilate or ventilate adequately. And none of them check CAS safety. So CAS is combustion appliance zone, and that's a weatherization test method for verifying that you won't backdraft the chimney after you make a building tighter. And that should be part of every insulation, air sealing, whatever installation that is done. Most contractors do wear personal protection, and the reason is that the owners of the companies don't want to lose their installers because they need people to spray the foam. Next, please.
We might have to make this the last one, Henri. We've reached the end of our time. So if you want to knock this one out, I'll close this out.
Okay. Well, let's go to the next slide. I think it's a better.
Nice.
This is there. You went by it. Back up. Yeah, that one. This shows you all of the kinds of. This one is if you're going to try to shoot straight up, put a full can on the gun, because then the liquid will go into the outlet. If you turn this steep with a can that has a low liquid level, you won't, nothing will come out, and then you lose all your pressure. Next slide real quick. Yeah, I just want to show that this is one brand, and all of their single component offerings. You know, some of these are for windows, some of them are cold weather, some of them are fire block is for doing around a chimney in the attic and meeting the code. And so there are a lot of products out there, so make a good choice when you pick a particular product.
Excellent. I think you did the best you could with the time allotted to really blow through all the questions we had available tonight. It does sound like we might end up with yet another visit from you because there's just
Right.
a lot of questions about this. So we'll get to that as needed, but we certainly want to thank you for your expertise and sharing it with us tonight. We also want to thank Dan Colbert for coming in clutch right at the 11th hour to save the day. And then
Nice
on
meeting
behalf
you,
of
Dan.
You too, Henri.
of Mike and all,
I think you should just rename the show BS and Spray Foam.
well, we might list it as that on Green Building Advisor, which is where you can find the recording of this if you want to reference any of the charts. I know Mike graciously offered to reply with a couple of things in email to people, but certainly all these shows are available there. So you can rewatch this and enjoy Henri's expertise for many years to come via the magic of the internet. On behalf of my co-hosts and friends, I want to thank everyone for joining us tonight, and we'll see you next time on the BS and Beer Show.